Okay, hello everyone. We're going to provide you solutions for self-select exercise number 9 covering thermochemistry lecture. So in the first problem, you ask to write chemical reactions, balance equations for each type of standard enthalpy changes. Okay. So in the first one, you should write enthalpy change for formation of ethanol. Okay. So let's start first ethanol. So it's C2H5OH. And remember the definition of delta A enthalpy change of formation, yeah? It's the heat change when you form 1 mole of substance from its elements under standard conditions. So you are forming 1 mole of a substance, so 1 mole of ethanol, okay? C2H5OH from its elements. So what elements do we have in the structure of ethanol? So we have carbon, okay? We have hydrogen, H2. So we should write as they exist, okay? As their elementary form, and O2. So as I said here, we should form 1 mole of ethanol. Therefore, all coefficients should be in accordance with that coefficient, okay? So I have 2 carbons here and 3 hydrogens and 1.5 oxygen, okay? So it's okay to have fraction number in front of these elements in order to get 1 mole of substance which is being formed, because we are writing for formation. Okay, and all states should be in standard state, so solid, gas, okay, gas, and ethanol is liquid at room temperature. So this is the enthalpy of formation of ethanol, okay, under standard condition. And the next one is formation of methane. So again, formation, that means we are forming methane, CH4, from its elements. So we have carbon here in the structure of methane and hydrogen, H2. Okay, so we are forming 1 mole of methane. So therefore, I have here 2 hydrogens, okay, and 1 carbon. And this is delta H of formation of methane. And under standard conditions, so standard states, the most stable state at room temperature, okay, and gas. And the next one is combustion of hydrogen. So combustion means we are burning a substance under excess oxygen, okay? So this is a heat change when you burn 1 mole of substance under excess oxygen under standard conditions. So we are burning hydrogen with oxygen. So burning, combustion means you are reacting it with oxygen, okay? And forming, in this case, water, yeah? So you must burn 1 mole of substance. So all other coefficients should be should rely on that coefficient, okay? So if you have 1 here, that means you should have 1 water here and 1.5 in front of oxygen, okay? And hydrogen is the gas, oxygen is gas, and water is liquid, okay, at room temperature. So this is delta H of combustion, the heat change when you burn 1 mole of hydrogen under standard conditions. So standard condition, remember, yeah, 25 degrees or 298 Kelvin temperature and 1 atmosphere pressure. Next one, so again combustion, we are burning ethanoic acid. So it's a heat change when you burn 1 mole of ethanoic acid with oxygen, so under excess oxygen. And in this case, all organic compounds, when they burn, they produce carbon dioxide and water, yeah? So again, yeah, it's an enthalpy change when you burn 1 mole of compound, 1 mole of substance. So all other coefficients should rely on that. So we have 2 carbons here and how many hydrogens? So 4 hydrogens, so 2 water here. So 6 oxygen and 2 oxygens here. So 2 plus 4, yeah, correct, yeah. Okay, so ethanoic acid is liquid, gas, and liquid, okay, water. This is the enthalpy change for burning 1 mole of ethanoic acid under excess oxygen, okay. Next one, neutralization between hydrochloric acid and sodium hydroxide. So we are reacting acid, hydrochloric acid, and base, sodium hydroxide. It's a neutralization reaction, which we get sodium chloride, salt plus water, okay. And remember, yeah, when you react acids and bases in neutralization, when you find standard enthalpy change, everything should be in aqueous. The reactant should be in aqueous state and with concentration 1 mole per decimeter cube. Yeah, and it's a heat change when you react acid and base to form 1 mole of water. So in this case, it's simple. So we already have 1 mole of water. Okay, so it's delta H of neutralization for hydrochloric acid and sodium hydroxide. Okay, it's aqueous here and liquid. What about next one? Sulfuric acid. Yeah, so we have sulfuric acid reacting with sodium hydroxide. So again, neutralization. That means you are forming salt, sodium sulfate plus water. Okay, so let's balance. So first, it's easy to balance first of all the reaction as it is. Okay, so you have 2 sodium here. That means you should put 2 here, and so sulfate 1 hydrogen. Okay, so you have 2 water here. Yeah. So again, aqueous form with concentration 1 mole per decimeter cube, aqueous and liquid. Yeah. But what's wrong with this reaction? Remember, yeah, it's enthalpy of neutralization is a heat change when acid and base reacts to form 1 mole of water. But here you have 2 moles of water being formed. Yeah. So therefore, you should divide all coefficients by 2. So we get 1.5 sulfuric acid, okay, plus 1 mole of sodium hydroxide going to form 1.5 sodium sulfate and 1 mole of water. Okay, so your aim should be to get 1 mole of water in neutralization. Okay, so you don't have to memorize all definitions. Okay, you just need to find keywords. So formation, that means you must be forming 1 mole of compound from its elements. Okay, combustion, you are burning 1 mole of substance with oxygen. Okay, neutralization, you are forming 1 mole of water. Okay, and all coefficients should rely on that. And the last reaction, so it's the enthalpy of reaction between aluminium and hydrochloric acid. Okay, so metal reacting with acid to form salt, aluminum chloride, and hydrogen gas. Yeah, aluminum is solid at room temperature. Hydrochloric acid is aqueous. Okay, and this one is aqueous. This is gas. Okay, so if we balance it, so we have 3 chlorines here. So 3 chloride and 3 hydrogen in total. So therefore I should put 3.5 here. But remember, enthalpy of reaction, standard enthalpy of reaction, is a heat change per mole of equation as it is written with the lowest ratio of coefficients. Okay, and the coefficient should be whole numbers. But here I have a fraction number, so therefore I should get rid of fraction here by multiplying the equation by 2. So I will get 2 aluminium solid, 6 hydrochloric acid in aqueous form, and 2 aluminium chloride in aqueous form, and 3 hydrogen gas. Okay, so do you see it's a enthalpy change, standard enthalpy of reaction for the reaction as it is written with the lowest ratios of coefficients and as a whole number, not fraction. Okay, let's move to the next question. So in this case, 2.8 grams of metal requires 10.1 joules of energy to change its temperature from 21 degrees to 36 degrees. What's this metal? Okay, so you have energy change here. So you have Q. Okay, you have your mass of the substance, and you have your delta T. Yeah, and you know the formula which relates all this. Yeah, mass, temperature change, and Q for energy change for a specific substance. Okay, so it is Q equals mc delta T. Yeah, and remember in this formula, Q should be in joules, mass should be in grams. Okay, and heat capacity is joule per gram, okay, per Celsius degree, and delta T is, it can be either Celsius degree or Kelvin. It doesn't matter when you calculate the temperature change. Okay, final minus initial will be same in any case. So Q is given, so 10.1 joules. It's already in joules. Okay, so you don't need to convert. Mass is given in grams to 2.8, and you don't know heat capacity. Heat capacity is constant for every substance, okay? So if you find the heat capacity, you can look up it from a reference book or from internet and find the identity of the metal, okay? So heat capacity and delta T is the final minus initial. So my final is 36 degree minus initial 21 degrees, okay? So Cp, if you calculate, you should get 0.24, okay? Let me just look from my notes. Yes, it is 0.24 joules per gram Celsius degree, okay? So if you look up what metal has this heat capacity, you should get it as silver, argentum, okay? So silver has this heat capacity, 0.24. Okay, next question. 100 gram sample of water at 90 degrees is added to 10 gram sample of water at 10 degrees. So you have separate water samples. Okay, so the first sample has mass of 100 grams. The second sample has mass of 10 grams. Okay, and the temperature of the first sample is 90 degrees. Yeah, and the temperature of the second sample is 10 degrees. Yeah. Okay, so remember about conservation of energy, law of conservation energy. So when you mix these two substances, yeah, the heat lost by one substance will be gained by the second substance. So there is no heat. The heat is not destroyed or created. Okay, it's being changed from one substance to another substance. Okay, being transferred from one substance to another substance. Okay. So, and also they will eventually reach the same temperature. TF would be same for two substances when you mix them. So, okay. So how do we find the energy change of water? So again, we use that formula, Q equals mc delta T. So the heat change by the first sample, Q1, should be equal to the heat change by the second sample of water. Okay. But one sample will have minus Q, okay, because it is losing energy. Its temperature is being decreased. Yeah? Or you can consider as a modulus of Q1 will be equal to the model of Q2. Okay, so Q1 is 100 gram mc delta T, heat capacity 4.18 for delta T. So the question asks us to find the final temperature. Yeah? So delta T is always final minus initial. Okay, temperature final minus initial for the first sample is 90 degrees, the initial temperature, and that should be equal to Q of the second sample of water. Yeah, so it is 10 grams. So Q1 equals Q2. Okay, the models. So 10 multiplied by 4.18 multiplied by temperature final minus initial temperature. So initial temperature of the second sample is 10 degrees, so minus 10. Okay, so here you can cancel the heat capacity because they are same, and you can cancel the zeros here. So 10 multiplied by TF minus 90 degrees, okay, equal, so temperature final minus 10 degrees. So if you open up brackets and solve for temperature final, you should get temperature final as approximately 82.7 Celsius degree. Okay, so it will be in Celsius degree because you used Celsius degree in your delta T value. Okay.